Good evening, ladies and gentlemen. Today we're on lesson 4 of module 3 and we're continuing with multiplying fractions. So we're on page 27. And what I'm going to get started with before is because we are using the algorithm or the standard algorithm and steps for multiplying. So I'm going to come next door and write my steps that are going to help me. So remember, my steps for multiplying fractions are very different than adding and subtracting fractions that we've done in the past. First, I'm going to set up horizontally, which is like this. And when I do that, I need to have a fraction times a fraction, which means I can't have any whole numbers or mixed numbers. It has to be a fraction times a fraction. My second step is I'm going to multiply straight, oops, I almost spelled that wrong, straight across. So I'm going to multiply straight across. And that's going to be the numerator and the denominator like we wrote before. Step 3 is I'm going to correct greater than 1 fractions. Greater than 1, and sometimes those greater than 1 fractions are also called improper fractions, but I'm going to correct them if I can. And then my final step that I want to keep practicing and getting better at is if I can simplify, I would like to simplify. So those are my 4 steps. Okay, so let's go on to number 1. Number 1 says, use the number line to represent the multiplication. Then write a repeated addition sentence to find the product. Okay, so even though we're going to do our way, I'm going to kind of look at this just to show what this means. So what they're saying is you have 3/4 of 3. So remember that's 3/4 of 3. So the multiplication is the same as 3/4 of 3. So what they show me here is I see 3 holes. So here's 1 hole, here's another hole, and here's another hole. And what they have said is they want 3/4 of the 3. So I'm going to say I want, of this one, I'm going to want 3 out of the 4, because that's what 3/4 looks like. And of this one, I want 3 out of the 4. And obviously, if you don't have a highlighter, you could be using pencil to shade. And here I want 3 out of the 4. So what I would end up with would be 1/4, 2, 3, 4, 5, 6, 7, 8, 9. So I'm ending up with 9/4, which if I do that in and out, or some of you are getting where you can do this in your head, I know 4 is my divisor, 9 is my dividend, so it goes inside, and I'm getting 2 1/4. So I think my answer is going to be 2 1/4 based on my picture. Another thing I could have shown is they asked for a repeated addition. They're saying that if I had 3/4 here, plus I had 3/4 here, plus I had 3/4 there. Well, I know that when I add fractions, I add the numerators, so 3 plus 3 plus 3, if my denominators are all the same. So I'm also getting 9/4. Now, if we did our strategy, I would set it up horizontally, having a fraction times a fraction. So the 3/4 is already a fraction. The 3 is not a fraction. So the way I can make the 3 a fraction is any whole number over 1. So 3 is the same as 3/1. Any whole number over 1. So I would get 3/1. And then if I just, so that's step 1. If I multiplied straight across for step 2, I would get 3 times 3 is 9, 4 times 1 is 4, and I'm still getting 9/4. So I like these methods because they show how it works, but this method is really fast and efficient when we get good at it. Okay, let's look at our next one. Our next problem says, use the tape diagram to complete the statement, then find the product. Okay. So this one I think is kind of confusing the way they wrote it, so we're just going to look at it. So they want this tape diagram. So they're saying I have 7 whole, and they cut it into 2 parts. So if I have 7 whole and I've cut it into 2 parts, well, if I put a 1 here and a 1 here, that's only going to be 2. If I put a 2 and a 2, that would be 4. 3 and 3 would be 6. 4 and a 4 would be 8. So putting 4s there was too much, but if I put 3s there, it wasn't enough. So if I think about it, I know that if I take 7 and I split it into 2, it's going to be 3.5. So I know it's going to be 3.5. But if I did this using my method, and this is where I like my method because sometimes these other parts get confusing. So I'm going to cross all these off. And if we just did our method, this is saying half times 7, which is the same as half of 7. And that's why we know it's going to be 3.5, because it's half of 7. But if we did our method and we said 1/2 times 7, well, step 1 says I need to have it horizontal, but I need to have it a fraction times a fraction. So I'm going to say 1/2 times 7 over 1. That's step 1. Step 2 says I'm going to multiply straight across. And I'm getting 7 over 2. And if I get 7 over 2, I know that that eventually equals 3.5, because some of you know how to just do it by looking, but if I don't know, I could do the division and I could work it out, and I'm going to get 2 as my divisor, 7 as my dividend, and when I do my division, I actually do get 3.5. So again, I could have read it as half of 7, and that would give me 3.5. I could have done the tape diagram, but I think always doing the straight algorithm makes it, at least for me, easier. Okay, let's look at these two, and they just say multiply, show your work. So if they just want me to multiply, I'm going to do my steps. So step 1 is I'm going to set it up horizontally, fraction times a fraction. So 3/5 is already a fraction, and 6 I can turn into a fraction by 6 over 1. That's step 1. Step 2 is I'm going to multiply straight across. 3 times 6 is 18. 5 times 1 is 5. Okay, so that was step 2. Step 3 says correct greater than 1. This is greater than 1. This is what we call improper or greater than 1. And it's because my numerator is larger than my denominator. So if I know how to just see it, which some of you do, otherwise I could do this to help me. I could put my 5 as my divisor outside, my 18 as my dividend inside, and I get 1 can't be divided by 5, but 18 can. And I could put 3 in each group. So 3 in each group is 15, and I'm going to be left with that. So I'm getting 3 3/5. And a quick reminder, that does make sense because I know that 5/5 is 1 whole, plus 5/5 is another whole, plus 5/5 is another whole, plus 3/5. So this is where the 18 came from. 5 plus 5 plus 5 plus 3 is 18 fifths. And this is where it equals 3 3/5, because that's 1 whole, 2 wholes, 3 wholes, and 3/5. Okay, our last one, I'm going to just use the algorithm. So I'm going to set it up horizontally with a fraction times a fraction. So 5/4 is already a fraction, and 8 can become a fraction like that. Okay, step 2 is we're going to multiply straight across. 5 times 8 is 40. 4 times 1 is 4. Okay, step 3 is I'm going to correct this because it's an improper or greater than 1 fraction, because this is larger than this. So I'm going to use this in and out method. And my 4 is my divisor. My 4 is my dividend inside. And I'm getting, okay, some people want to stop there, but remember when I divide, I have to go to the very end. So I have to go here. So this is going to be a 0. So I'm getting 40 over 4 is 10. And that's my answer. All right, ladies and gentlemen, we will practice this in class next time. Please make sure you always put a circle with a number of how you felt in the video. Do you feel like a 4, you could teach it? A 3, you could do it by yourself? A 2 or a 1 that you need some help from me? Have a nice night. Bye.